room, and we have also on the Zoom. Thanks a lot for the participation. So today we are honored to introduce our first speaker after the summer break, Professor Harlan Krumholz. So Dr. Harlan Krumholz is a cardiologist, educator, and scientist at Yale University and Yale New Haven Hospital. He is the Harold Hines Professor of Medicine and the founder and director of the Yale Center for Outcome Research and Evaluation, CORE, one of the most prominent research groups working to improve health and healthcare. Dr. Krumholz's work has improved the quality and outcomes of clinical decisions and healthcare delivery strategies and policies, reduce disparities, identify and address wasteful practices, and improve information flow and research knowledge pipelines. He has published more than 1,400 scientific articles and has an H index greater than 220. Dr. Krumholz co-founded the Yale University Open Data Access, the YODA project, designed to increase access to clinical research data and promote their use to generate new knowledge. He's a co-founder of Hugo Health, a patient-centric platform to give people agency over their digital health data, and also co-founder of Refactor Health, a healthcare AI augmented data insight company. Dr. Krumholz has been honored by membership in the US National Academy of Medicine, the Association of American Physicians, and the American Society for Clinical Investigation. He was named a Distinguished Scientist of the American Heart Association, and he received their Clinical Research Prize. He also founded the American Heart Association Quality of Care and Outcome Research Council and its annual conference, and served as founding editor of the Circulation Cardiovascular Quality and Outcomes. We also took this opportunity this week to share internally at BIHAM your inspiring piece published 10 years ago in Circulation to the younger researcher. A note to my younger colleagues, be brave. So the title of the presentation today is Innovations and Needed Improvement into Research, Ideas in 3 Acts. The current research ecosystem creates too much friction, delay, and expense for what is produced. There is a need to think about how we can create better pipelines of knowledge and accelerate our progress against disease that leverage the capabilities of the modern age. Harlan, thanks again for being with us today, and we are looking forward to listening to you.
Thank you so much for that generous introduction. And it's very nice to be with you, although it's so disappointing not to be able to travel to Switzerland and to be with you all in person. What a beautiful country, and every time I've been there, it's just so inspiring to be within nature and with people of Switzerland. But maybe another time. This is a talk that I want to stimulate some thinking about our own ecosystem, the place where we live, to try to generate knowledge, to try to help people throughout the world with their health. And yet I think it underperforms, as Boris said. The way I'd like to set this up is to present sort of a set the scene, and then to give sort of 3 areas that I think need very much attention, and pause after each one of those 3. I'll look at the chat and maybe just, I think rather than go all the way through, but we can have some questions as we go to try to keep things engaged. So with that, let me start. So I think you heard many of my disclosures that in the introduction, and just to put up that for a second. So to set the scene, I really think that despite all the exciting breakthroughs that are occurring within medicine and all the increased capabilities that we have compared to the past, well, there's actually reason to believe that there's it's a bit of a dismal time actually in research. And the harder we look, the more we find that should raise concerns for us about what we're doing in producing knowledge and the degree to which we can trust that knowledge, and what we need to do to strengthen our ability to make progress against disease. So, you know, there's lots of people that have been talking about this. John Ioannidis, of course, has one of the most, I'll call it famous pieces. This is actually less a research article than it is an opinion piece, but where he asserted why most published research findings are false. And he said it can be proven that most claimed research findings are false. Now, I think John overstated the case. He can do that from time to time if you know him. But he has an important point and also has pursued a lot of what is called meta research, research on research, to show many of the issues that exist within our fields. And this is one of it, again, one of his, I think this is a research paper. Notice single author research paper in 2005 in JAMA, where he talks about contradicted and initially stronger effects in highly cited research. Top journal, and he's talking about not research at the fringes, but highly cited research. And what he says is that contradicted and potentially exaggerated findings are not uncommon in the most visible and influential original clinical research. He finds that 16% of the top cited clinical research articles on postulated effective medical interventions that were published in the last 15 years, of course, this is in 2005, of course, so a little while ago, but no reason to think it's changed much, have been contradicted by subsequent clinical studies. And so contradicted, and then he also talks about how effect sizes in initial high-profile articles are much larger than what gets borne out subsequently. There's another article that was caught my attention. I think it's really a classic in the field that talked about the reproducibility of psychological science. And this was a consortium of some of the top investigators in psychology came together and asked the question, can we replicate the science that has been published? How well can we replicate these findings? And in psychology, you can replicate many of the experiments. In the world of medicine, there are some things which lend themselves to replication, especially earlier stage studies, but later stage studies such as clinical trials are harder to replicate, of course, more expensive, time consuming. But here, they conducted replications of 100 experiments and correlational studies published in 3 psychology journals, all using high-powered designs, and then they got access to the original materials that were generated. So this is a very high-powered group looking at what they were calling high-powered designs and had access to the original research materials. And so this is a figure, I think you have to look at this a little bit to really get it, but that shows the original study effect size versus the replication effect size. And also they're showing whether there was significant or not. So at the bottom, they have the original effect size on the x-axis, and on the y-axis, they have the replication effect size. So if you can exactly replicate the original study, it should be on that line of unity, the line that you see coming up there, meaning that the result in the original study is almost or exactly on that line, would be exactly the same as the one in the one that's replicated. And for sure, there are some studies that look like they replicate well, but there are a lot of studies where the effect size, notice it's biased downward. So the effect size is much smaller in that. And then you can see that there are a lot of dots, more than it seems, or at least half or more of the dots are non-significant. So when they replicated the study, the effect size was much smaller, and the statistical significance that they reported in the original paper could not be replicated. They concluded, well, let me just say, oh yeah, here's where it shows replication. So of the ones that they did these 100 consecutive studies, 97% were statistically significant. These were the published studies, versus 36% of the replications had significant results. So only about a third of the replications, virtually all of the original studies. So they really couldn't replicate them at all. Their conclusion was a large proportion of replications produced weaker evidence for original findings, despite using materials provided by the original authors. And in addition, here's what else they did. They review in advance the methodologic fidelity, and they had high statistical power to detect the original effect sizes. So this wasn't a type 2 error. This was, in fact, they were in a good position to replicate, had the original materials, had reviewed all of the methods and thought they had strong, the original methods, and they were being replicated, couldn't replicate them. And this is a different study that was more or less recently published that looked at real world evidence studies using clinical practice data. So they're using real world evidence. This is a group of also top investigators. Sebastian Schneerweiss, I think, helped lead this from Harvard. And this was very interesting. They sought to reproduce the results of 150 studies published in peer-reviewed journals using the same healthcare databases as the original investigators. And they also evaluated the completeness of reporting, because one of the things about replication is whether the original article has enough detail that enables you to do the replication. So they also evaluated the completeness of the information. But they looked at 150 studies. They used the same data. They went from the articles. They had top investigators looking at this, and they tried to see how well do the real world studies replicate. Well, one of the things they looked at was again, they're using the same databases. How do the patient characteristics compare when they tried to do the replication? So in this study, they're basically every one of the marks on the x-axis is a different study. So these are the 150 studies on the x-axis. They're just basically showing each individual study side by side. And on the y-axis, they're showing the difference from the covariates from the cell size. And, you know, if it was that you could exactly replicate the patient characteristics in the same database, it would all be zero, because the difference between what you saw in the original study and what you were able to replicate should be the same, no difference. That should be on the zero line. And you can see that there's there's a lumping of the observations along the zero line. They're looking at different characteristics, of course, but look, I mean, 0.5 or above or below, I mean, that 50%, that's pretty big. And you're seeing quite a splay for the different characteristics in the different studies. And then, excuse me, they're also asking the question, was the covariate code algorithms provided? So was it that they said, we use this database and we identified these characteristics, or did they actually reveal how they obtained those? And as you know, there's a lot of variation in how someone might define a particular characteristic, particularly in a claims database. And you can see this is all over the place for these different studies. So even just replicating the study sample, becomes almost impossible according to these folks. And then they were looking at, what about the results? So that was a study sample they had so much trouble doing. What about the results? Now, these investigators are aficionados. They're of real world studies. They're big proponents of real world studies. They're promoters of real world studies. So interesting, if you look at this paper, what they conclude is that there was mostly a correlation between the replication and the original study. But I think if you look really closely at this, so this represents the distribution of the hazard ratio, risk ratio, or odds ratio, depending on what the study was, and the distribution. So one, of course, represents that you were able to replicate the study. And okay, so there were a fair number of ones that are right around one. But there are a lot of studies that are quite different from one, and quite different from a 10% variation from the original study. And some that are as much as 30, 40% different from the original study, and some that are much, much different, a very few that are much, much different. So again, lack of replication, you know how much energy and promotion goes around a high profile article. And these are highly cited, discussed articles. Oftentimes clinical practice might turn on some of these patients or policies. And yet what we're finding is a very difficult job to replicate. So this represents, I just want to say, throw this one in, maybe a little bit of self-promotion. But I wanted to show you also like some of the concerns that when you really dig deep into these studies. So in this paper that we published in JAMA, our group, adherence to methodologic standards in research using the National Inpatient Sample. So our federal government produces a database that represents the healthcare utilization across the nation. Almost every state in our country participates. But they each have different sampling schemes. They have different ways of doing it. So there's actually quite strict guidance about how you can use these data to make inferences, particularly about trends. We have data over time, but also just other general inferences, because you have to take into account the study, the sort of design of how the sample was constructed. Because like I said, in the US, the way this is done is the states contribute the data, and the states have taken different approaches to the data. So if you violate this guidance, then the feeling is that you've essentially invalidated what it is that you've been able to study. And what we found was in a representative sample, we looked at all the studies that have been published from this. Then we took a representative sample of 120, just because we didn't have the resources to do all of them. So we took a sample. And we looked at the ones, this was published a little while ago, so during 2015, 2016. Though I can tell you we've repeated this study now, almost 10 years later, not quite. And there seems to be no change, but despite all the documentation, the required methodology, 85% of the studies did not adhere to one or more of the required research practices pertaining to the data structure, analysis, or interpretation. And we didn't look at minor criteria. These research practices were considered mandatory in order to make any sort of reasonable inference. And yet these papers get through peer review, many of them published in top journals, and yet they have violated the basic design principles of the database and should be considered invalid. And honestly, in my view, many of them withdrawn. So this thing about replication, in my view, is almost just the tip of the iceberg about all the things that are going on in our research ecosystem and what needs to be done to make things better. There's lack of reproducibility, but there's also lack of transparency. There's also a high degree of inefficiency and then expense, which is different than the inefficiency. And then the delays, and yet people are suffering and our research goes very slowly. So, this is our home. This is what we're basing our practice and policies on. This is many of us have spent our lives and careers trying to generate knowledge that's actionable. And yet, how can people trust what comes out of the research ecosystem? So I'll just pause 1 second. I don't see any questions or comments yet, but I'm just going to encourage you, if you have them as I go, that you should feel free to put them up. So I'll just keep going with the next part then. So I think the opportunities to improve are in 3 areas. And I think they represent data, sharing, and publishing. And so let me go start with data, and then again, I'll take another pause. So of course, data becoming ubiquitous, growing every day, and creating immense opportunities. And by the way, I mean, research has always depended on data. It's just that the nature of data continues to change. They're the reagents of our experiments. I mean, whether you're doing a randomized, non-randomized, whatever design you're doing, these are the reagents of our experiment. And yet these data are often not transparent, often not standardized, and not shared. I'll get to the shared in a minute. And providing limited opportunities for replication, actually. So I was impressed in psychology about the collaboration to try to do that replication. But in medical research, clinical research, health services research, excuse me, it often can be much more difficult. Sorry, just a little, my throat. So let me give you an example of what's going on in medicine. So this is a paper that was published in the New England Journal of Medicine by prominent researchers. The lead author is a very renowned, actually heart failure researcher, Mandeep Mehra. And this had a lot of fanfare. There was a lot of press. It was early in the pandemic. Using an observational database from 169 hospitals in Asia, Europe, North America, we evaluated the relationship of cardiovascular disease and drug therapy with in-hospital death among hospitalized patients with COVID-19. Now, you may know the end of the story. People started asking questions about this study and wondering about the provenance, where was this data from and how could they use it, which eventually led to a retraction. And you may know they had a paper in Lancet, they had a paper in the New England Journal of Medicine. This is almost unprecedented. I mean, a dual publication from a group like this on a database called Surgisphere, and both papers ended up getting retracted. And this is what they said: because all the authors were not granted access to the raw data, and the raw data could not be available to a third-party auditor, we're unable to validate the primary data sources underlying our article. We therefore request that the article be retracted. We apologize to the editors. So this is a very interesting turn of events. This happened at Lancet, New England Journal of Medicine, and they say because the authors were not granted access to the raw data, and the raw data could not be available to a third-party auditor. Do you know this is the standard across most large databases in the world? This isn't specific to this study. This isn't specific to this database. And it's fascinating to see that New England Journal of Medicine would withdraw it because of that. So meanwhile, just 2 weeks ago, this study gets published from Oxford researchers, Neurologic and Psychiatric Risk Trajectories After SARS-CoV-2 Infection, analysis of 2-year retrospective cohort studies. In this analysis of 2-year retrospective cohort studies, we extracted data from the Trinetics Electronic Health Records Network, an international network of de-identified data of 89 million people from the hospital, primary care specialist providers, most from the US, but from Australia, UK, Spain, Bulgaria, India, Malaysia, and Taiwan. These investigators, I know, don't have access to the raw data. If you ask them where the data is from, they can't tell you. Why can't they tell you? This is in the supplement. The network, the Trinetic Networks, contains data that are providing from participating healthcare organizations, each of which represents and warrants it has necessary rights. Trinetics, under business associate agreement, this is so long as their name remains anonymous as a data source and their data are utilized for research purposes. So Trinetics is a company, they've aggregated data. They can't tell you where it's from because of their legal agreements with the healthcare systems. They can just tell you what countries. And they aren't telling you how they process the data from the raw data to the analytic data set, for which there's a long road from getting raw data to actually turning it into something you can do analysis with. And I'm not, this is disclosed within the article. I'm not criticizing the Oxford researchers. They're free to do this, but it's remarkable that the Lancet and New England Journal would withdraw an article that had the same properties, that the researchers don't get access to the raw data and they don't know where it's from. And this is the rule rather than the exception. And I myself have published from large databases, and I'm now reflecting on this. I've done the same thing. So I don't want to suggest that I'm better than these people. I'm raising questions about what it means. And you're right. The comment is it's sometimes not allowed to see the raw data. That's my point. That they've got these legal agreements, so we're basically being handed something to analyze without understanding how it was transferred from that, and inability to, that pre-processing step is critical, and it's completely mysterious. Lancet has recently come out with I think Lancet Digital Health maybe, came out with a piece that says, what are best practices, framework for using electronic health records. I mean, this is just in this field, but saying we should have these standards. And they came out with all this stuff, that we should be doing. 100% agree that you should be able to have an understanding of how the structured data sets were identified and used. They should ensure transparency in their approach. They should detail how conditions and outcomes were defined. I mean, it's almost ridiculous that you would have to write this out, that you need to know this, but it is necessary, but no one's doing this. No one's providing this kind of level of detail. And in many cases, as I've just said, the legal agreements actually preclude it so that you won't need to know. So my point here is that we need to move from too many studies with mystery reagents. And I'm making the strong point that the distance between the raw data set, what you're actually getting, especially for real world, but this is true within trials or anything, like the distance between the cleaning the data. What's cleaning the data? I mean, the kind of work that needs to be done to put it in position to be an analytic data set, all of that needs to be clear. That's where a lot of the replication falls short. And we need to clean all of this up. So then, Sven, you say, so maybe we need less data to not generate harm from questionable analysis. Well, I think it's a question of how do you validate this? How can you trust it? If you're a researcher and you're putting your halo effect around it, your good name, your reputation, and in that case, Oxford standing behind the use of the Trinetics database, what would have to happen for us to have confidence that, well, it's a company, it must be okay. And this is Optum, IBM. There's others in the US, Komodo, Veradigm, Datavant. Now I'm just talking about a certain type of research. You know, I'm kind of going through all types of research have these issues. But this issue about the big data are such that what do we as a scientific community have to do to be able to trust it? Because it may look good, it may look great, the numbers may be large, but what have we got to do to give confidence in it and be able to even enable kind of replication that goes on and to understand that? So this is Act 1 is the data. I think we need to do a lot more work around how we're thinking about the data, the transparency, and the provenance of the data. Just pause for a second. People can keep putting them in, and I'm glad to keep going. Well, I think, Sven, you say the problem with real world data is we'll never know how it comes about. That is its nature. That's not true. That's not true. If I do a study at Yale, I can tell you where the data's from. I can tell you, I mean, it's possible to know. And so maybe, I mean, the way I'm thinking now is we need to build a consortium of healthcare institutions that want to work together and can vouch for their data and can tell you where it's from and tell you how they processed it. And I believe there are strategies to protect the data. Comment data protection is a problem, that for sure. But first of all, there are federated designs that are emerging and means by which we can do studies that can protect identities. And by the way, I mean, some of this, you know, in our country, the healthcare systems are selling their data to these third parties or giving it to third parties through these business association agreements to people who are selling their data. So we have a lot to clean up with regard to privacy. We're way behind Europe with regard to this, but we have all sorts of problems with this. But I think this is the least of it, because on the research side, we certainly have ways that we can keep this going. So the second act is around time to share. And this is another area that I've been working on for a while, in the notion that we need to move away from an era where an individual investigator can generate a data set and feel that they have ownership over the data and then can sequester it and use it at will without providing for other people to have access, and in essence, slowing down the progress and also making it so that it's impossible to replicate or to pressure test the findings within that study. I mean, we're all sort of socialized. Those of us of my age were socialized into thinking that, you know, these are my assets. I want our assets to be our ideas. I don't want the data to be a constraint. I want us to be working together against disease. I want disease to be the enemy that we're fighting, not each other. And I want us to be able to figure out how we can go as quickly as possible. So, you know, within this sharing is the issue of data, code, and tools. So, you know, data is, you know, what is the data, particularly raw data? Code shows you what's that pre-processing step, what's the analytic step, what did you actually do? And then tools can be such that, you know, if I've got data collection tools, you know, to what extent am I making so everyone doesn't have to reinvent things, so that we can come behind, we can use things like GitHub to share that. But even this code around the pre-processing step, you know, when lots of people look at code, people find things. And, you know, it's impossible to believe that every paper that's published has perfect code, that no one made a coding mistake. You know, we all have to be humble about our abilities. And in the idea of letting other people take a look at what we've used to create the knowledge needs to become normative. And I will admit it's hard, but it seems to me to be a necessary step. Again, going back to that article about the reproducibility of real world evidence, this is, remember I told you that they also looked at the degree to which people were sharing information. And so they created 6 categories for these comparative studies that looked at things like information that was being shared in the article about index dates, inclusion, exclusion criteria, exposures, outcome definitions, follow-up, definition of covariates. And so they said, basically, are they giving us enough information so that I could actually do their study? Are they telling me enough? And I've already shown you that people with the information that was provided couldn't even replicate the study samples, and let alone the outcomes. But what they saw was that the median number of categories where the reproduction team had to make assumptions in the replication because there was no information, not enough information in the original article to know what the authors had done, was 4 of these 6 areas. I mean, this is crazy. But I know that this is true, because I mean, I know it when I sit down with my teams, we do journal clubs, and the amount of things that you don't know how they did them or what exactly they did is large in most studies. And again, I'm not holding myself up. I need to do a better job on this too. We're working hard on that. I know I can do better. I'm not suggesting I'm any better than anyone else, but I'm saying that this is something that's not normative for us to be in full disclosure about what we did and how we did it. And I thought this was a good summarization of that. The issue, I think, about you know, how we need to strengthen science through the data sharing. Why share? Well, it can be that it ensures all data can be used to inform clinical decisions. It positions research as a public good. Even if it's been my idea in my study, there were participants, there were resources, often public resources. No person does this by themselves. It respects the contribution of the participants. Most people participating in studies want to see progress. They don't want to see that I become famous or that I have a bunch of articles. They want to see progress. They want to see what I've done contribute to as much good work by as many people as possible. And so that deserves some respect. It facilitates secondary studies, promotes reproducibility. I mean, all the things that I've been talking about. The ICGME, the International Committee of Medical Journal Editors, have weighed in on this. And they started saying manuscripts should contain a data sharing statement. And trials that began enrolling after January 2019 must include a data sharing plan. The NIH has jumped in and said, effective next January, proposals that they fund must include a plan for management and sharing of all data necessary to validate and replicate research findings. But the truth is, nobody's doing this. And there's no teeth really in this. People can hand wave at this, but it's not really happening. So these bodies are trying to push things forward. And David, I think, you know, I was going to raise this also in a later slide, but you know, this is a key question, right? So we sit within ecosystem. We have certain incentives. As generous and as we may be, we also have to, you know, people worry about their careers, and they're trying to figure out how to do this. It's up to us to design a system that rewards behaviors and actions that are in the best interest of patients and society. And when we have a system that rewards behaviors that are selfish, slow progress, and create choke points in the way in which we can proceed, then shame on us. Shame on our promotion committees. If instead of asking what have been your contributions and how have they been, are looking to see whether, you know, you singularly have produced a certain number of articles, which I've heard in my own place, or whether or not you're first or last, not giving any credit for members of a team in a world that's increasingly tacking towards team science. And I'm going to get to this in one second, but let me just say that part of it is also creating mechanisms so it's easy for people to find ways to share, because it also can be that you have the intent, but if there are no platforms, if there's no way to do it, I mean, as an individual, it becomes very difficult. Well, the NIH, National Institutes of Health in the US, has put up something called BioLink, the NHLBI, the National Heart, Lung, and Blood Institute, where they are facilitating the sharing of trials and resources. There are lots of other groups that are out there now that have come up that have sought to do sharing. And at Yale, we were, I think, early in this. We were the first group to set up a platform like this, where we said this is the Yale Open Data Access Project, where we would we would post trials, and our principal partner right now is Johnson & Johnson, and they made a commitment to share all of their clinical trials at individual participant level data, share all their trials. And that all people need to do is put in a reasonable request, and then to commit to publish whatever work they did. We also don't want to see the publication bias. And so you can look at the trials online, anywhere in the world. Any investigator here who wants to make use of a J&J trial can do that and have an opportunity to work on it in a sandbox. You can't download it and take it with you, except in unusual circumstances where what you need just simply can't be provided by the tools in the sandbox. We did an overview of this looking at 5 years, a couple years ago. And the experience so far is there are 421 trials currently available, and 86% of them through various people have been requested. There have been almost 300 requests submitted. We have approved almost all of them. It's just some of them weren't science at all, or people didn't know how to even construct a proposal. So, we go back, we give them guidance, but some of them don't resubmit. And we try to help people, to get some clarity. But the reason J&J put us in this position is so we can ensure there's no bias. Somebody wants to do a study that questions the findings of the original study, they can. This isn't a matter of, there will be no censorship. There's no decision about whether this is in the company's best interest. The only question is, this is in science's best interest. And, 104 manuscripts have been submitted, 77 published. None of those would have been published had this not been available. And, we're sort of showing this is cumulative, but, how we're growing over time. It's a free resource. And after we did this, many of the other companies followed suit with other platforms. But in academia, we haven't made any progress as far as I can see. That sharing, except maybe through NIH in some situations, is essentially non-existent. It's only industry currently that's doing that sharing. So this is the sort of end of my second act, which is we need to move to a culture of sharing, in my view. And David, this is where I was saying this Human Genome Project analogy, which was, so the Human Genome Project wasn't about how a small number of people like Francis Collins could, publish highfalutin articles and get, the kind of credit that they wanted. The goal was, let's produce data for the rest of the world to use to make progress. And let's ensure that it is in forms and formats that can easily be picked up and leveraged by other scientists. So the credit was that you were part of research that made it possible for other people to do research. And I think that maybe the best thing in our field is when we've done something to enable thousands of other people to do things that make progress. And that chain of credit, we need to pay attention to, like, why was it somebody was able to do that? What was the breakthrough that enabled that to happen? And, we've got to solve that problem. I think credit for what your team makes possible is part of that. And grants with a dual purpose, where the grant is for the question asked and to produce data for other people to use when the grant's over or in the midst of the grant. I think we need to make it so that if you don't share, it's a taboo. It's a taboo. We consider it rude, non-professional. And we need funding mechanisms for sharing to facilitate, so that it's not a burden on the investigator that detracts from other things. And this is something else we need to clean up, in my view. So I'll just go, unless someone has something, I'll go to the third. Please start. Go ahead.
Yeah, just you had some messages in chats. I don't know if you would like to have a look at them before you take your last.
So I've been doing them as I go. I think I've responded to everything in the chat so far.
Okay, perfect. I'm sorry.
No, that's okay. Because that's what I was saying to. I missed the one from Marcel. Is well organized and trustworthy remote access to the data as good as sharing? Yeah, I think so. Look, when we're doing the Yoda project, we had to negotiate with J&J about this, and they felt uncomfortable handing out the data for a couple of reasons. I mean, I think they want to be able to track what happens with the data, not tracking code or spying on people, but just to know if someone, are people working on it, and are they producing something? And we're the intermediary in that way. So they're not interfering with the science or having any special, look at what people are doing. But the other thing was a concern that we need to protect identities and privacy, and these data sets, in their view, shouldn't be circulating around. So we created a sandbox, where it has all the tools. People can work on it. They're private. We don't look at like people's code that's private, but it is accessible, but within in a remote way. And it seems to be working really well. The people who have used it have given us very positive feedback on it. So Marcel, I think it's a very good question. And generally, it seems like it works really well. Sven, is it only about sharing the data, or is even more transparent needed to understand the data, documentation, how study, especially trial, is conducted? Yes, I agree completely. That's why I said code and tools. I consider the tools to be anything that was used to facilitate the conduct of the study. So that includes everything you're saying, all that documentation, the code book, many of the top journals now require you to put in the study protocols, but everything that somebody would need to fully understand what was done, and if they were in the same position, could build it again and get the same result. That's what's lacking. That's truly what's lacking. So just to get to this final part, and then we'll open for questions again. I'll try to get this done so we have some time for questions, but to get to publishing and sharing. So I wrote this piece. You might be interested in it. I know Boris said he circulated the piece that I wrote to a young investigator. When I was editor, I would write a bunch of these kinds of pieces. And this is another one I wrote at the very end of my time as editor. I called it The End of Journals. So for hundreds of years, medical journals have served as arbiters of the quality of medical research, but the traditional peer-reviewed publication model is fraying. The hierarchical gateway to publication, historically in the hands of experts, is at odds with the ubiquitous democratization of data and information in the 21st century. And I go on to identify what I think are some of the critical shortcomings. Publications, these publishing empires, they're too slow, too expensive. They're charging us crazy amounts of money. Nature can charge like $11,000 to publish a paper. You have to be rich to be able to publish now. I know they provide some exceptions, but it's burdensome. Maybe in Switzerland you have enough money, but it's a lot. Too limited in the way that they think about what it represents a publication. In addition, too unreliable. I've gone over a lot of that. Too focused on wrong metrics. They chase these impact factors as if only the number of citations represent the quality of the science. It's just not true. And particularly some things get a lot of attention because of the fields they're in, or because they're simply articles that are good to cite in introductions to papers, but they don't represent breakthroughs. These journals and journal editors, I was one, I believe are too powerful, so much discretion. You can't even criticize them without knowing whether there'll be retribution. In addition, I just raised the issue too parochial, especially the US journals, too US centric, too static. They don't take into account interactive designs or presentations of data, and too dependent on a flawed business model. Although, Elsevier, Lippincott, I mean, these are billion-dollar enterprises, especially Elsevier. That's a flawed model, but it's worked well for a lot of people. So my conclusion is we arrived at a juncture where medicine science need new vehicles for the dissemination of knowledge. The new approaches enable us to separate the wheat from the chaff in order to better serve the public. The question for all of us in medical publishing, for those who consume medical knowledge, is how would this best be accomplished? And there's lots of issues. The friction in medical publishing also, I believe, contributes to this underreporting. You get studies that don't find significance or are in some ways have problems, but still represent literature, reasonable studies. It can be hard to publish even with all of the options available. Clinical trial results, you can't believe how many experiments on human beings never see the light of day, never get published. They get hidden. We started writing about this about a decade ago, a little more, where we started looking at studies that never were published, even NIH-funded trials that were registered in clinicaltrials.gov and were said to have finished. The investigators even put within clinicaltrials.gov that the trial was over, and yet never published. The results never posted on clinicaltrials.gov, never published in a journal. This is looking at months from the time that the study was completed. Look at the studies that were published. There's a slow rise. Even at 40 months, you're less than 60%. And then it flattens out. So a third of the studies, seemingly, even at 100 months, not published, not published. 50% of the trials are never published after as many as 2 years. And even when published, they often are only publishing a limited portion of the collected data. Patients and physicians make treatment decisions based only a fraction of the available clinical data that's out there because it's hidden. And meta-analysis and systematic reviews, they're incomplete because they can't see these results that are never shared. These are completed trials, by the way. These are not aborted trials. These are not trials that were ended and considered to be flawed. They just were never reported. And we also looked at a lot of this in a lot of different ways. We looked at time to publication among the completed trials. This is pretty much still true today, but this was, we were looking at this a while ago. Among the 1,336 trials published in 2009, the median time from the last patient follow-up to the publication was 21 months. So we tend to think about the trial that gets presented at the meeting with simultaneous publication and have a representative heuristic like, yeah, important trials must get published. But among those trials that were published, almost 2 years. So if we think we're studying things that are important to patients, we're taking 2 years almost. That, by the way, is the median time, 50 percentile for publication. And then Peter Bach, a friend of mine who does a lot of studies in oncology, they looked at 100 clinical trials in oncology where they had to have a press release and then the median time to publication, lots of SEC, regulatory, financial, regulatory issues. And they said among the 100 trials results press released from 2011, 2016, the median time to publication or reporting results. So a press release would come out and say, this is a positive study because they're under an obligation because of the financial markets to report something. So this is a positive study. The time to when results or publication are available, almost a year. So these are all issues, so it led our group to say, maybe there's a different way. And we started learning about these preprints. Preprints is a research manuscript yet to be certified by peer review and accepted by publication or journal. Preprint servers, an online platform. And we started looking around. I was influenced by a guy named Brian Nosek at University of Virginia, who'd done a lot of work in replication and was promoting the idea of preprint servers. And in social sciences, basic sciences, physical sciences, there's a lot of use of these preprint, but not in clinical science. And there are reasons for that. People concerned about early premature release of results and so forth. But I think there was a growing feeling among our group that we need to be able to get this out for discussion, for people to be able to have public dialogue, for there to be public review. And so we at Yale, along with some representatives from BMJ and from Cold Spring Harbor, who did bioRxiv, came together with a concept of medRxiv. And contextually and conceptually and technologically similar to bioRxiv, not for profit, a service, not a product, publisher neutral, operated by Cold Spring Harbor and managed with BMJ. And we launched it in Q2 of 2019, just before the pandemic. And this is like, people can just post. I say it's the director's cut. It's what you want to say as before it goes through the peer review. In order to make it safer, we put in submission requirements, posting criteria. We screen all the articles to be sure that there's not something in there that we thought could be harmful if wrong. Something that, might tell people to inject Clorox for COVID, something that we think is absurd and potentially dangerous. So and we end up screening out maybe 10, 15% of things for that reason. So we want to signal a need for caution, but we've had, the cumulative curve has gone way up and the submissions have continued to be strong. They spiked early in the pandemic when it was used as a means to communicate rapidly. But as far as we can see, despite concerns by publishers, this has become a public good within the research community. People can post it. It gets a DOI, an object identifier, so that it's going to endure. It's better than scientific meetings. Scientific meetings you present, often press releases come out. It's ephemeral. This is something you're putting up so your colleagues and others can see it, comment on it, with lots of caveats about it being preliminary. And we've had over 35,000 unique articles submitted at this point. I think 150,000 unique authors from 150 countries. And many of them, you can version these, version 1, 2, 3. And when it gets published, there's a link to what the published article looks like. You can see what it originally looked like and what happened through peer review. Only very few have had to be withdrawn. We haven't really had a situation like Lancet and New England Journal did with Surgisphere. And we've talked about that issue anyway. And about half have been COVID related. This just represents what you can see with a preprint. Lots of information. People can make comments. Lots of discussion on social media. So if it's not within the comments, this is an example of one that was posted by Peter Horby and Martin Landrau's group with recovery trials. They were able to post it early for discussion on medRxiv. And then you can see that it was then published in New England Journal of Medicine. You can see the preprint. You can see the link to the New England Journal, and then you can compare them if you want. And thus far, about a third of the preprints were subsequently published in 2,316 peer-reviewed journals. The median time is 140 days between that. You're asking, let's see, Nicholas, why so many unpublished trials? I cannot figure that out. I mean, do they lose interest? Did it not support the investigator's hypothesis? We have not been able to figure it out. I mean, it's a huge number and it's a problem. The question, no embargo problems with conferences? Nope, no. New England Journal came out strongly. Some journals, so we've done studies of the top 100 journals a couple years ago. 90% of them, preprints are not a problem. There are a couple laggards. Interestingly, American Journal of Public Health. For a long time, JAMA was a laggard, but they have a new editor who actually has avidly used the preprint server. Eric Rubin at the New England Journal of Medicine was a proponent from early in the pandemic about the use of it. He's a basic scientist and had been using preprint servers for his whole career. Lancet, of course, Elsevier has their own preprint server, SSRN. Lancet was an early promoter of this. So, but I don't think the journals should be able to dictate to us what the rules of the road are. If we think it's the right thing, then we need to be able to stand up for what we think is the right thing to do. So, I think, again, we need to address the properties of publishing that impede progress. By the way, there's a lot of things that I put in that end of publishing thing. I mean, even just this thing of the cost of publishing, the cost of open access. I mean, we need to be thinking, what kind of models are there that don't require people to charge us $5,000, $10,000, $11,000 to publish? And how can we improve all these different various facets of this, the transparency of the decision-making within peer review? Because right now, I don't think it has good reproducibility. Preprints can be a valuable tool. They're fast, free, and open. And we need a public conversation about whether the current publishing enterprise is best serving science and the public, or whether we need to redesign it to be better oriented towards what's in the best interest of the public. If research ecosystem is not what it should be, then our community needs to make it better. We're competing against disease and not each other. We need to support behaviors that put progress above personal gain and change the rules so personal incentives align with society's needs. Patients depend on us to do this. So with that, I just say thank you very much for your attention. So sorry that I couldn't be with you in Bern. It would have very much been my preference. And I hope sometime to be able to be with you and to enjoy the beauty of Switzerland and the stimulation of colleagues like you. Thank you so much. let's see. Let me just answer a couple of the more things in the chat. How did you organize that many important journals now allow having prior upload on medRxiv? Many people hated this idea, but they hated it for the wrong reason. They hated it because they wanted their journal to have the breaking news. They wanted to be the ones who got to be able to show people first look. And so it was really about, in my view, about them having preeminence over this information and being able to control when it was shared. If you look back at the Ingelfinger rule, this was Franz Ingelfinger, the editor of the New England Journal of Medicine, who implemented these embargoes. You look back at his original editorials, it does seem like we should be the ones to break it. We should be the ones to put it out there. And then did you see the exception they made? Because all of these people were also organizing scientific meetings. They said, of course, an exception is presenting an abstract or a talk at a scientific meeting. Well, why should that be an exception? I mean, that's like going, and American Heart Association, I'm a cardiologist, they have vast press hall and they're promoting with press releases this preliminary data in abstracts and oral presentations that have no enduring web memorialization, that there's no place to find them. There's no archiving of that information. And yet someone's going up for a 10-minute talk and somebody else is providing, lots of information about it. That seems to me to be, if you're allowing that, how can you be against the idea of someone posting what they're submitting to your journal? By the way, it also puts them on notice. We're going to be able to tell what peer review did because we can look at what the original looked like and we can look like what happened with peer review. And you're no longer going to be able to just say, we're so good with peer review. We'll be able to judge for ourselves because we can see the original. How were we able to do it? Because the research community started posting, and it becomes a competitive disadvantage. If you're going to say, we're only taking people who don't post, because actually more and more the investigators like it. It's an initial reward. I can show it to people. I can demonstrate what work I'm doing, and I can get feedback. There's a journal that's, I'll just do one or two more. I know I'm past time, so I'll just do one or two more. Sorry that I took so long, but I was trying to do questions as we went. There's a journal that's administered entirely through GitHub reviews, construction, final paper. Could a model like that work in medicine, perhaps? I think we should be open-minded to trying all sorts of different models. We should use the same creativity we're applying to our everyday work, the research or clinical care or policy responsibilities, whatever you're doing. You're focusing on that, but we need to pay attention to our own ecosystem, the way that scientific knowledge is organized, disseminated, and used requires our attention and care. We need to cultivate the garden that we want to be in. And it's up to us to be willing to try different experiments and evaluate them against the status quo to determine what's in the best interest. So I see it's 11:02 and I want to be respectful, but just thank you very much for your attention. You saw my email, you saw my Twitter. You feel free to email me or any questions or comments. Feedback.
I just have a question, sorry.
Yes, no,
please.
please.
Time to take a question. Just about this, congratulations for the great talk, and sorry if it is a bit noisy, I'm currently traveling, but I have one question about the unpublished trials. Did you look at the factors associated with being unpublished, for example, being funded by the pharmaceutical industry that doesn't want to get negative trial published?
Yeah, we've looked at this. I mean, in general, smaller trials are less likely to be published. Industry does better than academia. My colleague and now FDA commissioner, Rob Califf, likes to say that, they're these, he believes that they're these small, crappy trials, small, poorly designed trials that never get shown. But these even are NIH funded. Even if it was underpowered in the design, we still need to see what you found. It still needs to be shared. And by the way, when we were saying not shared, that's not published or posted on clinicaltrials.gov. people on clinicaltrials.gov, you're supposed to be posting results. People weren't sharing that either. So, but it's not definitive. Some large trials aren't shared. Yeah, there was no true pattern that would say like it's just a certain kind of trials. But yeah, smaller tended not to be published. The NIH didn't believe our findings, actually actively criticized us. And then they replicated it. And our paper was in, can't remember, maybe PLOS or something, but they replicated our finding, found the exact same result, published it in New England Journal of Medicine. By the way, didn't cite our original paper or even acknowledge in the introduction that they were replicating. And I asked the first author, why did you do that? He goes, it would have been hard to get in New England Journal of Medicine with a replication paper. That's NIH. Thank you very much.
Thanks.
Anyway.
And just about your wish, I will check with Paris that we organize an in-person visit in Bern likely for next year. So we have a bit of time to plan in advance.
That would be fun.
To visit Bern and also the different people attending the meeting. So thanks again.